Okay, Mr. Benson's not going to be here today. Whatever homework was due today, which was lesson 1.7, I will correct and collect when I return. So just keep that with your binders. I am not feeling well, and I apologize if I go into a coughing fit while I'm doing this lesson. But I wanted to give you the notes before or while I'm gone. Today, we'll talk about linear inequalities in one variable, meaning that there's only going to be one variable in that inequality. Our target is we can solve for all solutions of an inequality with one variable. Well, let's talk about what an inequality is. An inequality is a mathematical statement that shows a relationship between two quantities not equal to each other. We call that an inequality. I'm going to intentionally go fairly fast on this because I want to keep the file small. However, if I go too fast, just ask the substitute teacher to pause the video and so you can catch up. Let's talk about the symbols. If it's greater than, you read it left to right. So if something is greater than, that's what it looks like right there. So 6 is greater than 1. You read it from left to right. If you have trouble thinking about what is greater than, which one's less than, think that the alligator here is gobbling up the bigger number. The symbol for less than is the exact opposite. Greater than or equal to, once again, we go from left to right. 6 is greater than or equal to 1. 6 is also greater than or equal to 6, but that's what that line underneath means. And less than or equal to. Okay? Skills notes. An inequality is a mathematical statement that has a range of solutions. The open side of the inequality symbol is the greater side. When solving an inequality, you can follow the same rules as solving for an equation, except, this is a huge but, when multiplying or dividing by negative numbers. You can treat it just like an equal sign, just keep the inequality going, and you can add and subtract to both sides. You can multiply and divide by both sides, unless you multiply or divide by negative numbers, and we'll tell you what to do. When multiplying or dividing by negative numbers on both sides of the inequality, you must reverse the inequality. And we've got some examples down below that will explain this. When graphing inequalities on a number line, an open circle indicates that the circled number is not included in the solution. For example, a greater than or a less than. If something is greater than 6, it means it's larger than 6, it's bigger than 6, but 6 isn't included. If it's a closed circle, that indicates that the solution includes that number. So if it's greater than or equal to 6, then we fill in the dot on 6. And I'll have an example down here. When you are doing a number line, always include 0 on the number line. It is wrong if you do not. In graphing the inequality, when the variable is written first, points to the direction to shade, and we'll get to that in a minute. Let's take a look. Jamal's height, we're going to call that height h, is greater than 6 feet. So Jamal's height, h, is greater than 6 feet. It's not greater than or equal to, it's greater than 6 feet. Quinn has at most $200 in his savings account. Let n represent the balance of his savings account. Well, Quinn has at most, which means he might have $200. So we've got an equal sign there. And at most means that he has less than $200. So we're going to say at most 200. 200 is the largest possible amount, but the m, the balance, is less than 200, less than or equal to 200. Now, let's graph the inequality. Here we go. X is less than -6. So I automatically just put in a -6. It doesn't matter the scale. I always include 0. Number lines always have arrows at each end. And because it's less than, not less than or equal to, it's less than, I'm going to put an open circle around 6. Now, if you look up here, graphing the inequality when the variable is written first points the direction to shade. The variable is written first, and that is pointing me the direction to shade. So I'm going to shade that way, and that's how you graph that. If you don't remember that, all you have to do is pick another number. Is 0 greater than -6? Yeah, but we're wanting x to be less than -6, so it's going to be pointed away from 0. Once again, if I'm going too fast, just ask the substitute teacher to push pause on the video. Now, 6 is less than or equal to, I'm sorry, -6 is less than or equal to x. I put my 0 on the number line. I have my arrows on the number line. I've got my -6. This time, I'm going to circle it, and because it's equal to, I fill in that circle. This is how you graph an equal to, less than or equal to, less than or equal to -6. You just put the -6, and the shade points to the direction. Oh, take it back. Sorry. When the x is written first. When the x is written first, so I can reverse that. X is greater than or equal to -6, and that points the direction. I apologize. Right there. When the variable is written first, it points the direction to shade. Or I could ask, is 0 greater than or equal to -6? Yeah, so 0 is going to fall on the greater than or equal to number line, and yes, 0 in fact is shaded. Hey, turn it over. Now, when we solve for inequalities, we follow the same rules. I'm going to isolate the term with the variable. The term with the variable is w divided by 4. I have a +2 happening, so I subtract 2. Subtract 2. This +2 minus 2 cancel each other out because it's +0, and 0 is an additive identity. And I've got w over 4. I keep the greater than or equal to the same because I did not multiply or divide by a negative number. I subtracted 2, and 3 minus 2 is 1. Now, I've got w divided by 4. Inverse operation division is multiplication. I'm going to multiply times 4. What I do to one side, I must do to the other. And if it helps you, I can write that as 4 over 1. I cross cancel, and I'm left with w is, let's find out. Did I multiply or divide by a negative number? No, I did not. So I don't change anything. 1 times 4 is 4. Let's graph this thing. I'm going to write a 0 here. I'm going to make this a 4. And because the variable is written first, greater than or equal to, we're going to fill this in, and it shades the direction. That means all the solutions, 5 is a solution, 6 is a solution, 7 is a solution, 7.7 is a solution. Everything to the right of 4 or greater than 4 is a solution to this inequality. Let's take a look at this one. I want negative or positive variables. So I've got a 2p. How do I get rid of the 2p? I subtract 2p. What I do to one side, I must do to the other. I subtract 2p. I'm left with a 4p over here, plus 3. I did not multiply or divide by a negative number, so it's still less than -5. I subtract 3, subtract 3, and I'm left with 4p is less than, this -5 minus 3 is -8. Now I've got a 4 times p. The inverse operation of 4p is division, so I divide by 4, divide by 4. I'm dividing by a positive number, so I do not change the inequality. I'm left with p is less than negative 2. To graph it, draw my line, put my negative 2 in, always put 0, because it's less than, not less than or equal to, it's an open circle, and it points, because the variable is written first, it points in the direction of the shade. Or I can say, hey, if I put negative 3 in here, is that less than negative 2? Yes, it is. So the shade encompasses negative 3. Okay. Last two examples. I've got to isolate the term with a variable. I've got a negative 4z plus 7. I'm going to subtract 7. Subtract 7. Plus 7 minus 7 goes away. And I've got a negative 4z is less than or equal to 19 minus 7 is 12. Now, I've got a negative I've got a negative 4 times z. Inverse operation is divide by negative 4. Divide by negative 4. I just divided both sides by a negative number. I have to reverse the inequality. The negative 4 and the negative 4 goes away, and I'm left with a z, switch the inequality, is greater than or equal to 12 divided by negative 4 is negative 3. And go ahead and draw it on the number line. I have a negative 3. I've got a 0. I've got a greater than or equal to, so I'm going to fill that thing in. And I'm going to shade the way it points. That's it. Or I can ask myself, is 0 greater than or equal to negative 3? Yes, it is, because negative 3 is a negative number. Last example. 9 is greater than or equal to negative 3h plus 15. Subtract 15, because I'm isolating the term with a variable. Subtract 15, and I'm left with 9 minus 15 is negative 6, is greater than or equal to, this plus 15 minus 15 go away, and I'm left with a negative 3h. Now, I have negative 3 times h. I have to divide by negative 3. I have to divide by negative 3. And just like it says in the notes, if I'm dividing by a negative number, I have to reverse the inequality. So instead of greater than or equal to, it's less than or equal to. Negative 6 divided by negative 3 is 2. And when I negative 3 divided by negative 3 is 1. 1 times h is just h. And I'm going to rewrite this thing. Right now, it's open towards h. In order for me to do the point trick, I have to write the h first. And then we'll write it as h. This is open to h. So I need to keep it open to h. 2. Okay. I draw my number line. I've got a 2 here. I've got a 0 here. I have greater than or equal to, which means I fill it in. And it points to the right. So that's the way it shades. Or I can go up here and say, hey, is 3 greater than or equal to 2? Yes, it is. And that is how you graph or find solutions for inequalities in one variable. Let's take a look at the homework. In the homework, this first part, we're simply going to write an inequality with an x as a variable. X is what to negative 3? Well, it's pointed that way because it's shaded that way. The question is it equal to 2? No, because we have an open circle. So that's it, greater than 3. You're going to do the same for 2, 4, and 3. On this next section, you have to solve the inequality and graph the solution on a number line. So just like the notes, let me find one with a negative. I'll do number 9. It's probably the most difficult. Okay. I have to isolate the term with a variable. I'm subtracting 2, so I have to add 2. Add 2. Negative 4 plus 2 is negative 2. I did not multiply or divide by a negative number. I added 2. So I don't change the inequality. And minus 2 plus 2 go away, and I'm left with x divided by negative 3. Now, I've got x divided by negative 3 To get rid of the divide by -3, I have to multiply by -3. What I do to one side, I must do to the other. However, I just multiplied or divided by a negative number. So I have to reverse the inequality. -3 times -2 is +6. This -3 cancels with that -3, and I'm left with an x. Now, I need to rewrite it as x is it's pointing to x, so let's point it to x, less than or equal to 6. Now that's written with the variable first, I can use my little cheat on how to shade this thing. I've got a 6 here, I've got a 0 here. I'm going to fill in my 6. Why am I filling in my 6? Because it's less than or equal to, and I'm going to shade the direction the inequality points. Or I can ask myself, hey, x is less than or equal to 6. Is 0 less than or equal to 6? Yes, so 0 is going to be included in the solution. That's why I'm shading that direction. That should be it. Your homework assignment is to go all the way through 11b. This is the most important ones. Don't skip those.